We're starting a new unit today, sets and probabilities. When you guys get your notebooks back, we'll do the table of contents then. And everything that you're taking down today on your separate sheet of paper will basically be incorporated back into your notebook, okay? So these notes, they don't have to be super pretty or anything like that, but it's basically what's going to go on the page that's going to relate to sets, okay? Along with this goal, you'll be able to recognize different set notations as well as interact with the vocabulary and apply them to Venn diagrams as well. Before we get started on this particular unit that deals with probability and that deals with sets, there's a couple of things I need to kind of go over. You don't have to write this down, but there's just certain things that I need to make sure I say. In this particular unit, we're going to be investigating fair games, or like someone like rolling a fair die, et cetera, and then determining the probability of winning or losing, okay? And now you need to understand that, these are like the fundamentals of probability theory. Remember, this is the studies. It's like we're dusting off the dirt on the orange, okay? Your intuition can be helpful. You're like, oh, well, if you roll a die, the probability of it landing on a 4, is 1 out of 6. Your intuition is good. It can be helpful. However, sometimes that whole thought process you may have is not going to be correct. You're not going to end up with the right answer. You're going to need to depend on the theory of the fundamental theories of probability in order to get the correct answer, okay? So any of those hypothetical situations or any one of those like, oh, well, that doesn't make sense because of you got to base it off the theory, okay? So I'm kind of throwing this out there to kind of prevent any of those potential things that can happen, okay? Base it off the theory, okay? Follow the formula. It'll never steer you wrong. Sound good? So now that I got that out the way, let's jump into sets. So one of your opals, doesn't matter which one. If you're like, what's the order? But here's the first one, just kind of start just flipping in after that. Make sure you get this down. A set is a collection of objects, and the objects that are in each set are called elements. So get that down into one of your bubbles. Don't worry so much about what's in the purple. Okay? And so, what you see in the purple are different examples of sets that you could potentially have. As you can see, your set is identified with the capital letter, A, B, C, D, so on and so forth. And it's going to equal something that's in a pair of curly brackets. You guys have seen the curly brackets before, correct? Set notation when we were doing domain and range. So that's going to be a part of, how you write a set if you ever have to write out an example of a set. And each one of these pieces that's within it is called, is an object or an element. So 1 is an element, 2 is an element, so on and so forth. Okay? C, the names of students absent from school. I promise you, we are never at 100% attendance at Lake Forest High School in one day. We can run Genesis, get all the names of the students, and each person's name would represent the elements in that particular set. Okay? G, X such that X is a square number less than 50. Just to make sure that we're okay. What is a square number? Can somebody give me an example of a squared number? 25. Anyone else? Huh?
36.
What do you say? 9. I thought you said something else. 39. Okay, yes, 9. 49. 36. Cool. So we know what square numbers are, correct? In this particular one, we're looking for square numbers less than 50. 4 is 1. 1 is 1. 16. Less than 50. Okay, so you got to be careful because there are going to be some things where like, okay, well, 121 is a square number, but it's not in this particular set because it's not less than 50. So you want to be careful about that, and so on and so forth. So these are some examples of sets. Are we good here? Yeah. Now, to go along with this, there are a couple of other vocabulary terms I want to make sure that you guys are kind of aware of, okay? A precise set, okay? A precise set is one that's specific, okay? Like example A and example B, those are examples of precise sets because you got 5 numbers in them, 1, 2, 3, 4, 5. B is example of precise set, 4, 5, 6, 7, so on and so forth. You guys okay with that? Yeah. That word, precise? Okay? Not only are A and B examples of precise sets, but they're also examples of finite sets. What does finite mean? It has an end, okay? You have 4 elements in set A, or 5 elements in set A, you have 4 elements in set B, and so on and so forth. Would H be an example of a finite set?
No.
Why?
Because I'm not negative.
Huh? Because you can go negative, and technically you could go negative all the way to what?
Negative.
Into infinity. Okay? What about D? Is D a finite set?
No. Yeah.
If you say yes or no, I need you to tell me why. Justify your answer.
Because there's certain amount of numbers between 10 and 5.
We're talking about D, right? That's a zero.
0 and 5.
Zero.
Oh.
Z.
What number is greater than 10? But
Yes, it is.
All right. I heard someone say no though. Whoever said no, why do you say no?
That was me because I got it backwards. Like, I mean, no, like as in it, like no as in it like it finishes. Like.
So you're saying that it is a finite set?
Yes, but I said no because I was like talking about it being infinite.
Gotcha. Okay.
It's not.
So no one says that it's not finite.
Well, it could be if like the decimal kept going and never ended.
This isn't a finite set because of exactly what she said. Between 0 and 5, there are infinitely many numbers in between. There's not just 1, 2, 3, 4. It's not just those.
So how
It's
would
1.5.
H not be one either? Because you could have like 199 point, like decimal going forever.
H is one.
No, H is not one.
I mean, not like.
Yeah, H is not finite
Oh, it's
because
not
because
that reason.
because of that reason. The exact
I
same
thought it
reason.
was finite.
The exact same reason. Okay. Is G a finite?
No.
Yes, it has to be a whole
Yes.
number.
Yes, it is because yes, they do have to be whole numbers to be your square numbers that are less than 50, and so on and so forth. So are we good with finite?
Yes.
Talk about element. Two other things. Actually, one other thing. If you see this notation right here, okay, you've seen that N before. Where have you seen that N before? Say what? The total amount of terms back in what concept?
Numbers.
I heard it, Johnny. What you say? Arithmetic sequences and things like that. You remember that N is representing your number of terms that you plugged in? Okay? That N is still very similar. Except this time, instead of saying, the number of terms in a sequence, it's the number of terms in set A. Or the number of elements in set A. How many elements are in set A? So N of A would be 5. Because there's 5 numbers in that set. You see what I mean? What will be N of B? 4, because there are 4 numbers in set B. You can only do this for finite sets. Okay, what about N of G?
You have to know the number of how many there are.
Okay, so how many of those are there?
There's 4 guys. Come on, 4. 16.
1,
1, 4.
Oh,
36.
7.
46.
6, 7?
7 times 7 is 49.
I got 4.
1 times 1 is 1.
Let's them out. 1 times 1 is 1.
2 times 2 is 4.
It's 7, yeah.
3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49.
And after that, you're greater than 50. So that's a total of 7. Okay? So if you see something like this, it's asking you how many numbers are in those respective sets, whatever's in the parentheses. Make sense?
What for F?
Huh?
What for F?
Well, for F is actually interesting because it's saying the set of p-values such that p is a prime number and a multiple of 10. Somebody give me an example of a prime number that's also a multiple of 10.
5.
Multiple.
Oh.
That means they get bigger. It gotta be a prime number.
I don't think it exists.
It can't because how can you have a multiple that's also a prime number?
Yeah, okay.
What's a prime number?
Prime number is not
It has no multiples exactly except for 1 in itself. So if you have like 20, 20 is not a prime number because there's always going to be a factor of 10. So this would actually be an example of what's known as an empty set, which I was actually going to go over later, but I can mention it here. It'll be an empty set where literally you would have 2 curly brackets with nothing in between them. Okay? In other words, there's no elements that actually fit this particular example. Does that make sense? Okay. Empty set could also be written with a circle and a slash through it. No curly brackets, but just that notation. So if you see either of those, that means it's an empty set. Okay? How are we so far with the vocabulary? Yes?
I'm confused on finite. What is it?
Finite means that it ends. Like there's only a certain set of numbers that can fit in that particular set. So A is an example of a finite set because you only have 5 numbers that are in that set. You can have 5, you can have 10, you can even have 20 numbers. But there's not that uncertainty of there potentially being like a decimal or infinity or anything like that. H is not an example of a finite set because it's asking for all the x values that are less than 200. And there's no way you could potentially list all the numbers that are less than 200. It's not possible. You'd be going on forever.
You say finite doesn't like include like any decimals?
In this particular, it could include decimals, but it would have to have a certain number of decimals. Like there has to be a stopping point.
Opposite of infinite.
Yeah, not the infinite. Opposite of infinite. Any others? Okay. On your next bubble, okay, we're going to be talking about a little bit more with sets. This one we're going to be talking about a universal set that's denoted as U, must be stated in order to make a set well defined. Now this picture that you see with the rectangle and the U that's outside of it, that is the notation to represent the universal set. You always have to have that rectangle in order to classify sets. Okay? That could be, like with Venn diagrams, the 2 intersecting bubbles and things that you guys did back in like elementary school. You need to have a rectangle around it to represent that universal set. Without it, you will lose points. Okay? That universal set is usually defined in all your problems. So then that way you know, okay, what set of numbers or what set of topics am I talking about that are going to be inside of that? Okay? Questions? So, consider this problem. We're talking about the months of the year that begin with the letter J. The universal set would represent the months of the year that begin with the letter J. January, June, and July. That is our universal set. Those are the only months out of the year that we're considering. Okay? So April, May, October, you'll leave those alone. Okay? Now it says set A is defined as the set of all months which end in uary. Okay? On your desk, I want you to draw what this Venn diagram would look like. I'm going to give you a minute to do that. You are representing this universal set and set A in a visual.
I never needed to know my
So, one thing that I know is on some of you all's boards is that you're already wrong, which means that you weren't listening to me. What is the one thing that I said you always need to have?
A box.
The box. You need to have the U. When with the U comes the box. You can't have the U without the box.
So wait, did I do this right or
Okay, well hold on, we're piecing it together, okay? So some of you guys, you were missing that. Because if it says anything about a universal set, bump that. You always have the box, okay? Doesn't matter. So you always have the box. Now it says set A is defined as all the months that end in uary. Well, out of our universal set, there's only one month that ends in uary, correct?
Yeah.
Okay, so that was January. So that meant that January needed to go inside of one of those circles inside of your box. Now I have a question. Why did some of you all have 2 circles?
I don't know.
Are there 2 sets? Is there an A and a B?
I think this is the Venn diagram part. Yeah, you can Venn diagram.
Is this an A and a B? Is there an A and a B set?
January is both, right? Yes. Because J and then U.
True.
From that set of data, though, right?
You only take it from that set of data.
Okay, so we don't need February.
Yeah, you don't need February. But again, I go back to my question. Why do some of you all have 2 circles when you only have 1 set?
Because it says
No.
It's like a Venn diagram.
That's a type of Venn diagram.
What?
Yes. Venn diagrams are not this right here. Yes, this is a Venn diagram, but it's not the only Venn diagram that you can have.
Right?
No, it's expanding on what you know. Okay? So this is an example, but this does not represent this particular example because you only have a set A. There's no extra set, so there's no need for a second circle.
So you do what's outside the circle. What do you need other stuff?
So you should have your universal set. You should have one circle to represent set A. And what goes inside of set A? January. Now, are there any other elements that are in the universal set that aren't in set A? June and July. So where do June and July go? On the outside of the circle. This is what you, I know, you did very well.
I don't get it.
Okay? Okay. So, what we're going to talk about now is another vocabulary term, which is called a subset. All right? Now you'll need two circles to do this. But can you please just copy down the first circle so then I can give you an example? And make sure everyone's clear on the word subset. And then I'll have you write down the second oval. So then that way I can do an example so we won't, mix and match them. Okay. Go. Every element in a given set M is also an element in another set N. Then M is a subset of N. That notation for subset is it's a C with the line underneath it, okay? So they can either use the word subset or they can use the symbol. So you do need to know the symbol, okay? So what does that mean? What does that look like, okay? That's like saying, you'll see a better example, but just in general, you'll see a better example later, but just in general. If you have set M that has these three elements, and you have set N that has these three elements, then they are subsets of each other. Every element in M is in N. No extra. Nothing missing. Okay? Now, if you're like, well, they're nothing but just the same set, so why don't they just call it the same set? A lot of times, subsets aren't written exactly like that. They might say something like this instead. The set of x values such that it's between 1 and 3 x. What does that symbol mean right here? Integers. Integers are what types of numbers? Whole numbers. That can either be positive or negative. In this particular example, they only want the whole numbers that are in between 1 and 3 inclusively. This, what I wrote, is basically 1, 2, and 3. Does everybody see that? But it's written differently, but they're still subsets of each other. You see what I mean? So that's what you're more likely to see. The numbers in the set? No. Mm-mm. Questions on subset? Okay. So go ahead and get down the one for proper subset now. Okay. So a proper subset, not to be confused with a subset. As you can see, the symbol, proper subset, doesn't have a line underneath it. Subset does. Of a given set is one that is not identical to the original set. Every element in M also lies in N. However, there are some elements in N that do not lie in M. The most basic one would be an example like this. M is a proper subset of N. As you can see, every element in M also lies in N. However, it is a proper subset because if you look at the elements in N, 3 is not an M. Okay? Difference between a subset versus a proper subset. Questions on this terminology? We're going to let U be the months of the year that end in ber. A is going to be the set of months that begin with the consonant. B is going to be the set of months that have exactly 30 days, hence why you need to know how many days there were. What I want you to do is I want you to draw a Venn diagram that shows each of these three situations. But just to make sure that we're okay, I only want you guys on your desk to do A. Okay? So we'll start with that first. I want you to draw a Venn diagram that shows sets U and A in a Venn diagram. Gonna give you a minute. The main thing is you need to know what are your months that end in ber. What are they? September, October, doesn't matter that I'm recording y'all to sound just terrible. November and December. So instead of just saying, that, hey, that is what the set is, they can also say that. How many elements are in the universal set? So there should be 4 months on your diagram, correct?
Yes.
Okay. Now A says that the months that begin with the consonant. Consonant is what? Not a vowel. So that's what? September, November, and December. So instead of just writing out what the actual months were, you had to think a little bit, hopefully not too much, and figure out what those months are. Okay? So, did everybody have a rectangle?
Yes.
As you should. Everyone should have had the rectangle and labeled it U to represent the universal set. Now, I need to have all 4 months inside of this box. How many circles do I need? Just 1, because I'm only talking about set A. What's going to go inside of set A? Because we've already wrote them out. November and December. Do I have all of the months that are in my universal set?
No.
What's missing?
October.
Where does it go? Outside the circle, but inside of the rectangle. And that's what you should have had.
What happens to B?
We're not on B yet.
No, but it doesn't.
So this one only concerned U and A.
So we were only doing A?
Yes.
The consonant is a word.
All right. Clear your desk. Do B now.
A-E-I-O.
They showed it, but I didn't pay attention. The words were right through.
All right. So in this one, did everybody have their rectangle?
Yes.
Okay. How many circles did you have in it?
1.
Just the 1, because we're only dealing with 1 set. That's B. B are the months that had exactly 30 days. Went over this. Which ones have 30 days that are in the universal set? September and November. October 31st is Halloween, and December 31st is New Year's Eve, okay? Are there any months that are outside of the circle? October and December. So this is what it should have looked like. It doesn't matter where they are as long as they're within the respective rectangle. We're good?
So if that were a problem, your answer would be both those together?
No, it wouldn't be both. It'll be something based like what I have. It'll be 2 separate universal sets, like what I have up here. If this was one problem, you would just have 2 separate universal sets. Clear your desk. Now you're doing the last one. Now, if you noticed, I put what each set was. I have the universal set up there in orange with all 4 months that are represented in our universal set. In A, we have those months that begin with a consonant. And B, we have the months that end exactly 30 days. Do you notice anything?
We already did the work.
Say what?
September and November is in the circle.
September and November is in.
For both of them.
Can you elaborate some?
Like on the separate ones, they both have September and November.
Oh, A and B both have September and November in it. That's what you're saying? Okay. Anything else you notice?
We did it.
Say what? They both have A and B do not include October, so that means October is going to be on the outside of the universal set. Anything else? Who's going to get the gold star?
Smaller and like less
No. No. Use our terminology that we've been talking about.
It's a universal set.
Subset. Proper subset.
Which one is a proper subset of the other?
B is
B is a proper subset of A. So I'm going to write that out real quick. Different color, okay? B is a proper subset of A, which basically means that all the elements in B are in A. Is that true? It is. So because of that, yes, you are going to have 2 circles, but they're not going to be intersecting like what I'm seeing on some of you guys' desks right now. Okay? The reason why is because all of set B is within set A.
Oh, you put it inside.
So you have to draw it inside. B is inside of A. This is what an example of a proper subset looks like.
Would a regular subset be a Venn diagram?
A regular subset would actually be just two overlapping circles, because that means every element in one is in every element of the other. So it would be the same circle. So September and November go in B, and since B is inside of A, that means that September, November is also in A. December is in A, but it's not in B. And October is in the universal set in neither A or B.
Can you do one for subset? Like just draw like a real quick picture? I'll put it in the same.
It'd be the same circle. A little bit more vocab. An empty set, like I mentioned before, is actually a subset of every set. So this symbol also means empty set. Remember, this symbol as well means empty set, and every set is a subset of itself. Okay, we are going to get into the ones where they do have the intersecting circles, okay? Bring in some terminology that you may have experienced before. First one we're going to do is intersection. What is in the orange that you see is the symbol that represents intersection. It's an upside down U. I would suggest drawing the Venn diagram as well, so you can have that visual there. Drawing that universal set can be helpful if you need to look back and reference what exactly is intersection. So that notation down there in the orange that's inside of that universal set is A intersection of B. You could also have B intersection of A. It's basically the part where they overlap. It's the part where they overlap. Now, there's a difference between this and the picture of the proper subset. This would indicate that there are some elements in B that aren't in A. Okay? There's some elements in B that aren't in A. That's why you would have two intersecting circles like that. Does that make sense? The English version of what intersection would be is and. Okay? So if it says that, sets A and B, that would indicate intersection. All right? So, any questions on intersection? Well, let's see. On your desk, let's do some examples, okay? You're going to do all of them on your desk, okay? It's the same A, B, C, and D from one of the very first slides, okay? Do be aware that I did add in that less than or equal to in B, and that says elements of, what's Z mean again? Integers, very good. And I want you to write down the sets of A intersection D, A intersection B, D intersection E, and C intersection D. I want you to do all four of those on your desk. I want you to write down the sets. So, me, I've always been the type, especially with ones like this, at least when I'm teaching, to go ahead and just write out what each of the sets are if they're not explicitly given like A is or like D is. Okay? What are the elements in set B? 1, 2, 3, 4, 5. 0 is not included. 5 is. It's only the integers. So A is a subset of B. What are the prime numbers? That's also a multiple of 10. Nothing. There's a difference between an empty set and 0, so be careful. It's an empty set. D has all my elements. And we talked about this before, but what are the square numbers less than 50? Cool deal. So here are all my sets written out and listed. So I'm looking for the intersection between A and D. I'm looking for where A and D overlap. I'm looking for what A and D have in common. What numbers do A and D have in common? So it's the set 4 and 5. You can write it just like this, or you can just write with the curly brackets, okay? But you need the curly brackets to identify that it is a set. What do A and B have in common? Where do A and B overlap? What's the intersection of A and B? 1, 2, 3, 4, 5. Questions on the first two? Let's look at this C. We're looking for the intersection between intersection between D and E. It is just 4. 4 is the only squared number that lies in D and E. And what about D? What's the intersection between C and D? Nothing. One of these is an empty set. Okay? So there's nothing in common between an empty set and the set that has something. Questions on intersection? All right. Clear your desk. Here's the next oval. Union. It's the opposite of intersection. It includes everything that's in A or B or in both. The word that's associated with union is the word or. Okay? So it's in both. So in this picture, all of this is shaded. Okay? Everything in A, everything in B. Everything in their overlap. On your desk, you are doing A, B, and C, standing up. Okay?
Wait,
So that means.
you put Jesus anger.
So A, union, D. Remember, union means or. Union means everything that's in A, D, the overlap, everything. So in unison, because y'all are chatty, so it must mean y'all prepared answers. In order, what is A union D?
1, 2, 3, 4, 5.
I said union like you in church. 1, 2.
3, 4, 5, 6, 7.
Good stuff. What about A union B? In unison.
1, 2, 3, 4, 5.
Awesome. And what about the union between C and D? In unison.
4, 5, 6, 7.
Awesome, because the empty set, there's nothing in there. So it's nothing plus everything else. Have a seat. Next person, I see a hand on their face, we're going to have some issues.
Yes,
All right, this ain't morning meeting. You don't need to talk, sit down. Last bubble. Your last oval is compliments. Your last bubble is compliment. And there's actually 3 Venn diagrams that I want you guys to get down. At least get one on your oval. If you want to do the other ones in your notes, that's fine. But at least get one down inside of this oval. On your last oval, you're putting compliments. Those 3 orange markings are different ways that compliment can be represented. It's basically an apostrophe, okay? Sometimes you see the apostrophe like a curved symbol. Sometimes you'll see the apostrophe as like a straight tick mark. Sometimes you'll see it as a vertically stretched C, but they all mean the same thing. They all mean compliment. No, they will not have like all 3 symbols in one problem. It would be one or the other, okay?
Is it the purple that we're talking about or the white?
In this particular picture, the purple represents the compliment. Okay, the purple represents the complement. The word for complement is not. So it basically represents everything that's not in a particular set. As we can see in this example of this Venn diagram, the only thing that's not shaded is A. So this is an example of A complement, this picture. It's everything that's not in set A. Okay? Other ones. Here are a few other ones as well. Okay? I definitely want you guys to get these down because complement, when you start adding in the other symbols with it, it can get kind of a little confusing because you're looking at multiple things. Okay? So I do want you guys to get these down. In these types of problems, sometimes you will be asked to shade certain regions that represent, things like what you see in the orange, A intersection B complement, or the intersection of A and B and the complement of that. Sometimes you'll be asked to shade certain regions, so it's important that you kind of know how to do that. Part of your homework, you are going to be doing some shading as well. They're going to give you basically a sentence, and they're going to ask you to shade the region that represents that sentence. So just to help you out, especially when it's combined with other things, what I like to do, you don't have to do this, but for those who, if anybody's having in their mind, like, where in the world did they just get just A shaded? Okay? Think of it like this. I have two sets, A and B. And what I'm going to do is I'm going to shade A, because this right here represents A. So I'm going to shade A in yellow. All of A in yellow. Is everybody with me? Next thing I'm going to shade is B complement. B complement stands for everything not B. So I'm going to shade everything that's not B, which is going to be everything outside of circle B. Is everybody with me? So the yellow represents A, the green represents not B, and now it's asking me to find the what? The intersection. The intersection is where they what?
Oh, shoot.
Where they have in common, or where they,
It's the intersection of
or where they overlap.
So it's like the intersection.
The yellow and green overlap right there.
That's what I do too.
And B dash is where B dash is.
Because
And then
like
they
the
intersect.
apostrophe, you think it's like after. I thought it was A intersecting B and everything not that.
That's what the one with the red shading represents. If they want that, they'll put parentheses around it. Okay? So, in the one over here, look at the inside of the parenthesis, the intersection between A and B. The intersection is the part right there, in the middle, where they overlap each other. So the complement would be everything that's not shaded in black, which is everything shaded in red below it. You see how it works?
What's colored in is what's selected.
What is colored in represents the statements right here.
So the complement just says basically what you can't color in.
Correct. And make sure that you're aware of what the apostrophe goes to. In the first example, the apostrophe only went to B. But in the second example, it went to that entire intersection part. Okay? Your turn to practice. Here we go. On your desk, you're going to draw the Venn diagram to represent this situation for F, G, and U. And then I want you to write down what are the elements in F complement, F intersection G complement, and F intersection G, the complement of that. U is always a universal set. So U will never be a circle. U is always a universal set, so it will never be a circle. But inside of U, you should have had two circles that intersected each other, one labeled F, one labeled G. Neither F was all in G, and neither G was all in F, so that's why there were two intersecting circles. Now, what do F and G have in common?
6 and 7.
So what they have in common, where they overlap, should go in the middle, the intersection between the two. What numbers are just in F, but not G?
4, 5.
What numbers are just in G, but not F?
8, 9.
And are there any numbers that are in the universal set that are neither
10.
in F or G? So boom, that's your Venn diagram. Now you have to write down everything that's not in F. Everything that's not in F is basically what's not in that circle. What numbers are not in that F circle?
8, 9.
So that's your answer for the first one. Did you guys get that?
Yes.
For double I, it's F intersection with G complement. So that's F, not G, and where they intersect, which is right here. What numbers are those?
4 and 5.
So it should have been 4 and 5 for 2. And the last one is the complement of the intersection. So what's the opposite of that shaded region? Everything else. So it should be everything except this little bit. What were those numbers?
4, 5, 8, 9, 10.
4, 5, 8, 9, 10.
Why can't number 2 have 10 in it?
Because you're looking for the intersection between the two areas. So 10 is in the blue part. It's not in where the blue overlaps the green from this drawing up here. That's why it doesn't include 10. We're looking at where they overlap each other. All right? We're going to do this one together. Just make sure you guys can kind of understand what's going on here. It says, in this Venn diagram, each dot represents an element. So each dot represents some element of some kind. It could be a number, it could be a name. Doesn't really matter, but it represents some element. It's asking us to do n of g. What does the n mean?
No.
How many are in G?
2.
There are 2 dots that lie just in G. Does everybody see that?
Yes.
So it's asking you how many are in each set. Now it's asking you for n of f. Before we shout out, think about it. How many dots are in f? I was going to do a countdown.
6.
I was going to do a countdown. How many?
6.
It's 6. 2 in G, the 3 that are just in F, and then that 1 that's in the intersection. Technically, all those dots still lie in F. Everybody get that? Okay, I'm going to do a countdown with my hand, and I want you to tell me the answer to C. The number that's in G symbol F. 2. Okay? The intersection between G and F. So basically it's what the 2 have in common, where they overlap. Considering that G is inside of F, it's technically what's in G. Now the next one. The number that's in H symbol. What does that symbol mean? Not combination. Complement. So think about it. How many?
10.
It is 10. Okay, there are 10 dots that are not inside of that H circle. The next one, I'm looking for the number that's in F intersection H. Exactly, there's only one that's actually an intersection between F and H. Any questions up to here? Okay, look at the next one. The number that's in between the intersection of G and H. 0. There are no elements that are in between G and H, or that intersect between G and H, because they don't even intersect themselves. Does everybody see that? Yes. Jesus. True or false? It's asking you, is the number of elements in F union H equal to the number of elements in F plus the number of elements in H? Okay, I'll give you a few seconds to think about this one. G, true or false? It's false, because how many are in the union? 8. How many were in F?
6.
How many were in H? And 3 plus 6 does not equal 8, so this one was false. Okay? The last one, it says the union of G and H. How many elements are in the union between G and H? Remember, union means together.
3 or 5.
There's 5. 2 in G, 3 in H, so together that makes 5. How many were in G? How many were in H?
3.
Is 2 plus 3 5?
Yes.
So this one is true. There's one more example that I will do after you guys leave, and then I'll post the video. Make sure you watch that example before you guys do your homework, okay? For the last example, it's just some practice with shading. So you're going to shade the region on the Venn diagram that shows these different sets. If you notice, this is an example where you have 3 different sets together. And so you're going to shade basically the region that represents this. So if we look at A, I'm going to kind of break it down the easiest that I can, okay? So we're going to be looking at the union of A and B, and then the intersection with C. So I think one of the easiest ways to do this is just to say, okay, well, let's just take it piece by piece. What is the union between A and B? So we're going to shade that. The union of A and B is this area right here. What is in A or B or in the intersection? So this right here with shading in yellow represents this first part here, A union B. Now what I'm going to do is I'm going to shade C. Okay? So I'm going to shade C with this, I don't know, ivory looking color. And that represents C. Now to put it all together to get your final answer, we need to do this here, which represents the intersection. What is the intersection between the yellow region and this tannish colored region? And that's where they overlap, which is right in here. So what's shaded in the pink is actually your final answer. The pink represents A union B intersection with C. All right, and for the last one, it's A union B intersection with C. So we're going to break this down into pieces as well. Okay, we're going to shade A, we're going to shade the intersection between B and C, and then we're going to see what everything is shaded to represent the union. So we're going to shade A, and then we're going to shade B intersection with C. So we're going to shade the intersection of B and C, which is right in here, is where they overlap. And it doesn't matter if it overlaps with part of A. We're not even looking at that. We're only looking at where B intersects with C. And then our final answer is the union, which is everything that is shaded, which is all of this. So what's shaded in the pink represents your final answer, okay? And that's what you're going to have to do for your homework, all right? So if you need to, go ahead and kind of draw out, like shade your different regions and see, you know, are you looking for the overlap or are you looking for everything that they have in common? And that's going to represent what your shaded region is. Please bring your questions to class.